Good afternoon, children. In the Zoom classes, I have taught you about the valence bond theory, where we have learned about the bonding made by coordination compounds. But there are certain limitations of valence bond theory. The first limitation is it involves number of assumptions. It is tetrahedral, it is octahedral, and so many of them. The second assumption is that it does not tell about the magnetic data properly. It does not give any interpretation of the magnetic data. For example, if there is a 1 unpaired electron, it is paramagnetic. 3 unpaired electron, then it is paramagnetic. The third limitation is it does not tell about the color of coordination compounds. All the coordinated compounds are colored, but it does not give any idea of the color of coordination compounds. The fourth one is it does not tell about the thermodynamic and kinetic stability of coordination compounds. It does not tell about the value of delta G, enthalpy, entropy of coordination compounds. It does not tell about the rate of coordination compounds. The next limitation is it does not distinguish between strong field and weak field ligands. The last one is that if the coordination number is 4, it may be square planar or it may be tetrahedral. It does not predict clearly which one is tetrahedral and which one is that of a square planar. So a new theory that is known by the name of crystal field theory that has been explained, which tells about the bonding between that of a metal ion and ligand. In the valence bond theory, all the bonds were covalent in nature, but in the crystal field theory, the bond between metal and ligand, it is purely ionic in nature. The ligands are considered as point charges. There is an interaction between metal and that of a ligand. If the ligands are anion, like chloride ion, bromide ion, so then the interaction is ion-ion interaction. If the ligands are neutral, that is water, ammonia, then these are ion dipole interactions. I have shown it by the diagram that these interactions are ion dipole interactions. Now, crystal field theory tells about the bond which is formed between metal ion and ligand. There are 5 d orbitals. I have made shape of them: dxy, dyz, dxz, dx square, y square, dz square. All the 5 orbitals are having same energy. That means they are degenerate. Now, the ligand can give electron in any of its orbital, and there will be a creation of crystal electrostatic field around the orbital. But when the ligand approaches one of these orbitals, there is a repulsion between the electrons of metal and lone pair of ligand. This repulsion is responsible for raising the energy of these d orbitals. The field produced will not be symmetrical. If these ligands are in approach or they are pointing towards the ligand, so the energy will be raised. But if they are not pointing towards the ligand or they are away from the ligand, in that case the energy will be lowered, as there are total number of 5d orbitals, dxy, dyz, dzx. We here the approach of ligand will not be direct, but in this case where these orbitals are present on the axis, the ligand will be approaching directly. These are towards the ligand, so that is why the energy that will be raised due to repulsion. Here the energy will become higher and here the energy will be lower. Now I will tell you how does the electrons enter and what happens in the case of octahedral compounds and tetrahedral compounds.